1-1 basic equations. So the first thing we're going to talk about is solving linear equations. An equation is a statement that two mathematical expressions are equal. For equations, we want to find the solutions or the roots, and those are the values of the unknown or the variable that make the equation true. Solving the equation is the process of actually finding these solutions. Equivalent equations are two equations that have the exact same solutions. And then this symbol here that looks like kind of a double-ended arrow, this means equivalent to. So if you're in anything in Google Docs or Google Slides or anything like that, if you wanted to type that symbol, what you'd want to make sure you did was to put the less than, then the equals, and then the greater than. And then when you hit space after that, it'll just automatically turn into this symbol. So just kind of a little trick. All right, so there's some properties of equality when we're talking about equations. So the first one is if I know that two things are equal to each other, A equals B, then I can also assume that A plus B is equal to B plus C. So if I add C to both sides of my equation, equality is still there. Same goes if I were to multiply both sides, as long as I am not multiplying by 0. So these properties are requiring that you perform the same operation to both sides of the equation. A linear equation is in one variable, meaning there's only one unknown in the problem, is an equation that is equivalent to one of the form ax plus b is equal to 0, where a and b are real numbers and x is a variable. So any linear equation we can make go into this form. All right, so what we're going to do is to determine whether each is a linear function or not. So if it is linear, remember we just said we can make it look like ax plus b is equal to 0. So if we take a look at a, can I turn this into ax plus b equals 0? Well, let's try to make it say equals 0. That'll give me x squared plus 2x minus 8 equals 0. That is not of this form. So this is non-linear. This is not linear. It's non-linear. It's actually, if we look at it, it's actually quadratic. Okay. The next one, can I turn this into ax plus b is equal to 0? So if I subtract 2x from both sides, I'm going to be left with 0 equals. That's good. That's part of it. Let's see. That's negative 3 over 2x minus 7. Or we could have moved everything to the left. Regardless, this is definitely a linear function. If we take a look at the next one, I could just subtract 3 from both sides. I'm going to get 4x minus 8 equals 0. Definitely linear. All right, D. Remember, this x over 3 is really like saying 1/3 times x. So we absolutely can continue to do this. If I subtract 1/3 x from both sides, I'm going to get 2/3 x minus 6 is equal to 0. That is definitely linear. If I take a look at E, it already says equals 0, but I see an issue right away. There's a square root symbol, so this is definitely nonlinear. And for the last one, there is no way I'm going to get this x into the numerator, so this again is going to be non-linear. Whoops. Okay. All right, so let's solve some of these. So the first one we have is 7x minus 4 equals 3x plus 8. It doesn't matter if you want to deal with your constants or your variables first, but I always like to do the variable first. So I'm going to subtract the 3x from both sides. I'm going to get that 4x minus 4 is equal to 8. I'll add the 4. 4x is equal to 12, and then I'll divide and get x is equal to 3. Hopefully this is very much so Algebra 1. All right, number 2. So we have x over 6 plus 2/3 is equal to 3/4 x. So what's really nice about a problem like this, even though it looks terrible, is that if we can find a least common denominator, then we can multiply by it to make all of the denominators disappear. So I have a 6, a 3, and a 4. So the least common denominator of 6, 3, and 4 is going to be 12. So I'm going to multiply everything on both sides of my equation by 12, and that's going to make sure all my fractions disappear. So when I do that, I'm really distributing over here. Technically, what I'm getting is 12x over 6 plus 24 over 3 equals 36 over 4x. But I can really switch. I don't even need to write that step out. When I do this multiplication, I should see that's going to give me 2x plus 8 is equal to 9x. And then I don't have any fractions to deal with. I'll subtract the 2x. So I'm going to get that 8 is equal to 7x. And when I divide, I get a fraction, and that's okay. We're going to leave it in proper. So x is 8/7. I can always double check my work by replacing anywhere I see an x with the solution that I got. And I want to check, does the left side equal the right side? And it will. Okay. All right, so let's take a look at the next one, if it'll let me switch. All right, super messy, looks worse than before, but it's the exact same concept. If I can find my least common denominator, my life is going to be much easier. Now, in order to find my least common denominator when I'm talking about expressions, it's really helpful to make sure that I factor. All right, so in order to factor, let's take a look. We need to really just figure out this denominator over here. Everything else looks nice and factored. So I have the 1 over x plus 1. Plus I have 1 over x minus 2, and let's see, that x plus 3, but what multiplies to negative 2 and adds to negative 1? Well, that's going to be an x plus 1 and an x minus 2. All right, so we want to figure out what is the least common denominator here. If I can figure that out, then I'm going to have a much easier time. All of my fractions can disappear. It looks like if I made all of the denominators x plus 3, x minus 2, then I wouldn't have to worry about fractions anymore. All right, so I'm going to multiply the left side by x plus 1, x minus 2. I'm going to multiply the right side by x plus 1, x minus 2. Again, I'm going to write out this step, but you don't need to write this out if you can do this in your head. So I'm going to take both of these guys and distribute them to the purple fractions I have here. That's going to give me 1 times x plus 1 times x minus 2 over x plus 1 plus, again, when I distribute 1 times x plus 1 times x minus 2 over x minus 2. And then on the right, I'll get that x plus 3 that's already there times the x plus 1 times the x minus 2, and then I have the denominator. Again, feel free if you can skip the step, go ahead. I just want to show you what's happening. So if I look at my first fraction, the x plus 1s are going to disappear, and I'm left with just the x minus 2. Okay. If I take a look at the next one, the x minus 2s disappear. I'm left with just the x plus 1. And if I look at the right side, my x plus 1 and my x minus 2 are going to cancel, and I'm just left with x plus 3. And this equation is so much easier to deal with. X and x makes 2x. Negative 2 and 1 makes negative 1 is equal to x plus 3. And now it's a very simple problem to solve. I'll subtract x. I'll get x minus 1 is equal to 3. And when I add 1, I'll get x is equal to 4. Hopefully that shows up on your screen. So we want to just double check that this does in fact work. We should always check our answers. Hopefully x is equal to 4 is the correct answer, but we always want to check by going back and using substitution. So here's where I'm going to put x's on the left. I'm sorry, 4 on the left, and here's where I'm going to put 4 on the right. And I always want to just double check my answer. Okay. So when we check, let's look at the left-hand side. LHS for left-hand side. That's 1 over, we're going to put in a 4, so 4 plus 1, and then plus 1 over 4 minus 2. So that's going to give me 1/5 plus 1/2. All right, when I add 1/5 and 1/2 together, I would need a common denominator, which is going to be 10. So that's really going to be 2 over 10 plus 5 over 10. So I should get 7 over 10. That's what the left-hand side gives me. Now let's double check, does the right-hand side give me the same thing? All right, that's going to be a 4 plus 3. There's that 7, that's looking good. Over 4 squared minus 4 minus 2. All right, our numerator is 7. Our denominator, that's 16 minus 4 minus 2. So that's going to give me 16 minus 4, which is 12, minus another 2, 7 over 10. Awesome. They match up. So x equals 4 is definitely the correct answer. I'm in good shape. There's my little check mark that I'm all good. Same concept here. We are going to multiply by the least common denominator. Remember, everything can be a fraction. We can always put it over 1. Looks like x minus 4 is really the only denominator going on here. So I'm going to multiply both sides by x minus 4 to get rid of our fractions. So when we multiply by the least common denominator, our fractions disappear. Again, I'm going to write the step out. You don't need to write it if you know how to do this in your head. So x minus 4 times 2, technically over 1, plus x minus 4 times that 5 over x minus 4 is equal to, and we have x plus 1, x minus 4 over x minus 4. Again, you don't have to write the step if you know how to do this. All right, so the 1 means nothing, so I really just have 2 times x minus 4. Okay. In the next fraction, my x minus 4's cancel, so I just have a 5. And in that last fraction, my x minus 4's also cancel, so I have x plus 1. And now it's just cleanup time. I'll distribute my 2. So I have 2x minus 6. Oh, sorry. Nope, not 6. Minus 8 plus 5 is equal to x plus 1. So that's 2x minus 3 is equal to x plus 1 minus the x. X minus 3 is equal to 1. And we will add the 3, and we actually get 4 again, which is kind of interesting. Again, I want to double check my answers, but 4 should work. Let's just make sure that is the case. All right, so when I check, again, I want to do the left-hand side, get an answer, and do the right-hand side, get an answer. If they are the same, we're in good shape. So that's 2 plus 5 over, we're replacing it with 4, minus 4, 2 plus, that's 5 over 0. There's a problem there, huh? 5 over 0 is undefined. It's okay to have 0 on top, but it's no good to have 0 on the denominator. This is undefined, so this answer does not work. We call this an extraneous, like extraneous solution. So that means there are no real solutions to this problem. Okay. All right. So when we are multiplying each side of an equation by an expression that contains a variable, it's very possible to introduce something called that extraneous solution. So that's why we always want to double check our answers. All we have to do is make sure that we are testing